Hey everyone, welcome to the second part of this series. If you haven't watched it before, the link for the first part will be in the description of this video. In this second part, I would like to tackle how we achieved the results that I did on the renderings. You might have seen them. And for that, we're gonna see how we can set up a few loops to take care of the extrusions on the surfaces and separate these. There are a few techniques that can be used to achieve those things, and I'm gonna show you guys how I did this in this specific case, and I hope this could be interesting for you guys. So let's get started. I'm gonna if you don't have this file, this will be also available on my Patreon. But if it's just not that complicated to follow if you watch the first part of the tutorials. So I'm gonna start coming here and laying down just a null array, just so we can separate these two pieces of the setup. Just append it down here, set the display flag on, alright, and since we can vary the seed with however we want right here, right? I would recommend us to maybe lock, the result after we have found a layout that pleases us. One possibility of doing this is just locking the null down there, so it's just gonna freeze its current state, so it won't get altered even if we try to change the seeds. Alright, so we're gonna go down here on the null, and there is this little display here. There's a little icicle. Just gonna click there, so nothing happens. This will stay like this, so we can work down here, and you won't have problems like with this setup being reloaded at each time if you change the seeds or anything like that. Alright, so what we're gonna do is set up a foreach loop once again. So what we want to do here is we want to consider each of these primitives separately, right? So for that, we're gonna use a for each point and gonna change this on the end right here to piece elements for primitives, and we're gonna connect them together. So right at the bat, you should see that when you click the display flag on the beginning right here on the begin, it's gonna isolate one of these pieces, right? So there it is, and we are going to think about this for a second. What do we want to achieve, right? We want this to be a random extrusion, right? We want this at the end to have like a huge field, and each of these single elements have a different height on the extrusion, but we want to be able to set up also thresholds, so it has to be like a minimum height and a maximum height that we can set up. And we are going to need for this, just like we did above, we needed like this iter, it's this metadata. We're going to need it here as well. So for that, I'm going to click on the begin and click create meta import node. Alright, I'm going to rename this to extrude iter. Alright, so I know which iterator I'm working with, and I'm just going to lay down a poly extrude node. Okay, I'm going to put it right here in the middle of this loop. Okay, and if we jump right here and I'm gonna show you guys what's happening right now. So let's just say I want this to be extruded by the distance of 0.2, okay? And if I put the display flag on the end, you're gonna see that every piece got the same height as expected. And for us to change that, to randomize this height, we're gonna use this extrude iter here, since it has this if you come to your geometry spreadsheet right here, since it has this iteration number here, it's a detail attribute, we can use that as the random seed for our in our random function inside this poly extrude, okay? So let's do that for now. I'm gonna come to this poly extrude, I'm gonna click on the distance right here, and first of all let's just put the display flag on that one first, so we know what we're working with. I'm gonna start typing here. The first function we're gonna need is rand, okay? Open and close parentheses, and the random function takes in one argument, and we're gonna feed in that detail attribute that we talked about. So I'm just gonna type your detail. It's also a function to call a detail attribute, open and close parentheses array. I'm going to type the reference, so it goes with those two signs right there. I don't know the name exactly. Point and /, and I'm gonna type the name of the node that we just renamed. It's this extrude iter, right? And I'm gonna go put a comma and type the name of the detail attribute that we talked about, another comma and 0, since this is a one-dimensional attribute, and we want the first value, the first one and only value. Alright, so right at the bat you see that something happened, and if we check the result of this function right here on the extrude, you're gonna see that the distance got set to 0.60, right? And that happened before because the random function always returns a value between 0 and 1. And actually this could work for us, right? This is going to be done for each and every element of this loop. Each time it's going to be a different value, and this right at the bat works as well, but we don't have much control over it, since every value it's going to be a random number between 0 and 1. Okay, so I'm gonna just put this display flag on right here, and you're gonna see that it indeed did what we expected to do, but we don't have much control. Okay, so let's take care of that right now. I'm gonna go back to the poly extrude that we talked about, and for that I'm gonna use a fit function, fit01. So right in the beginning here I'm gonna type fit01, open parentheses, and then go back right here, close it, go back inside, open a comma, and takes in two other arguments right now. So it's the first minimum, the new minimum, excuse me, which I'm gonna set it to 0.1, for example, comma again, and 0.3. Okay, and you're gonna see the range gets refitted into this new range that we typed. So one thing that we can do right now is go back up there, since we got this control node right here that we did for the first part. We can reutilize this, so I'm gonna just drag it down here. So the things that were there, they can just keep there. It's no problem at all. Let's just make some room for us right here. I'm gonna jump inside the parameter interface from this control node that we created before, alright? And I'm gonna create two new values, okay, two new floats. And this is going to be extrude min par, okay, and extrusion min. Just give it a range from 0 to something, like let's just keep it low for now, 0.2. You can even come here to the second channels right here and type like a default value for this. So we're gonna go ahead and say this is a 0.1 is a default. I'm gonna apply. So this gets created right here, extrusion min. I'm gonna select the extrusion min right here, and I'm gonna press the key D as in double or as in duplicate. This gets duplicated, and then I'm gonna just rename this to extrude max parm, so extrusion maximum parameter, and I'm gonna leave it at the same. I'm just gonna change this value to 0.5, for example, as a default. I'm just gonna hit apply and accept. So we have these two values right that we just created, and we can just come here to the control and copy them. For example, copy parameter on the extrude min for starters. Just gonna come back here to this poly extrude. I'm gonna delete the value that we hard coded right there, and I'm gonna right click and I'm gonna paste relative references. Okay, and I'm gonna do the same for the second one. So extrusion max, copy parameter, go back to poly extrude, delete hard coded value. I'm gonna right click and I'm gonna paste relative references. Okay, so this gives another layer of control. So let's test it out, see what happens when we change these values. You see that they change right at the bat, giving us some more control about how our extrusions look like. Okay, so this is the first part, and the next thing I would like to show you guys is a couple of techniques on how we could achieve something like selecting randomly a set of these primitives and treat them differently, like having them have a higher extrusion or a lower extrusion, and maybe assigning different materials to them so we can random them out like with a glow material, just like you saw on the renderings that I did, or something like that, or whatever you want. Just a couple techniques on how to randomly selecting some of these. So let's get to it then. There is this one technique. There is extremely simple, and it uses the sort node. Okay, so I'm just gonna show this real quick, and then I'm gonna show you guys another option on doing this with vex in a wrangle, which is also a very interesting technique. So for those of you who don't know the sort node, it's very simple. It just it can, for example, randomize the order of the primitives or the points, in this case for the primitives that we want. The primitive sort, if I click on random, okay, so they get instantly assigned a different and a random primitive number, and we can alter them with the seed parameter right here, which is awesome. And we can use that, for example, to delete and create two streams of primitives and work them separately on two loops. This is one option. So I'm gonna just show you guys how we can do that. One way would be using like deleting by pattern or by range here, but we can do something even more simple. I'm just gonna type in the group right here on the delete from 0 to, for example, 70. So it's gonna delete the first 70 primitives on the order. Since they are random, it's a great effect. So you can just change the seed on here, and you're gonna see they all alter accordingly. And this is good. So I'm just going to put this to the side and copy and paste, like with the alt click and drag. And for this first, now we have two of them, and I just have to make them always talk to each other. So whenever I change one of them, the other changes accordingly. So I'm just going to set this first one here to delete non-selected, so we get that selection of primitives, alright? And I'm gonna copy the parameter here on the group on the first delete, and I'm just going to paste it on the second one, okay? Paste relative references, and this little function gets copied right there. And if I put a merge down here, okay, and do it like that, we're going to see better yet, let's just delete this. I'm just going to show you, for example, if I copy this whole loop right here and put it right there and assign these deletes to the different loops, just like that. Very simple. I'm gonna merge them together, okay? And I'm just gonna put the display flag on right here. Nothing changes because we haven't changed the extrusions right here, okay? Because if you take a look, this is and this is very important too. So this loop right here, this poly extrude is actually getting the data from this node right here, which is essential for this to work. So you can see when we copied this over, the reference here changed as well, so that's perfect. And we could tell, for example, we could say that the parameter right here, the minimum, we could multiply this. So this is the beauty of Houdini. You can multiply things. Whenever you have a field like this, you can make operations inside functions, and this gives you so much power. And just gonna do it like that, just to show you guys how this could be one approach to this, okay? And or you can even create new values right here to have even a greater control. So a new two new parameters right here, and this would work perfectly as well. So this is one technique that I wanted to show you guys with the sort. As you can see, it reacts accordingly right here and works perfectly. There is another one that I would like to show you. So let's just get rid of everything that we did and delete this side of the network that we did, and let's append a primitive wrangle right here, wrangle, and this wrangle is gonna handle the randomization variant of our primitives, okay? So first of all, I'm gonna come here and I'm gonna create it's actually going to be a float, but I'm gonna cast it as an attribute so we can see and use the spreadsheet right here as a debug, kind of. So I'm gonna call this cell, kind of a selection or whatever, and I'm just gonna say that this selection equals to the random function, okay? Open and close parenthesis, and put this semicolon to finish the line. And I'm gonna say that this random function should use the prim num, which is the current primitive number, as the seed array. So how this primitive wrangle works is that this goes through every run over every primitive. Okay, so just like loop right here, this is, you could even say this is the same. Unless you put like the tail, then it's gonna only run once as a code. But if you put like any primitives, points, vertices, or numbers, this is going to loop over each of the numbers or each of the elements that are currently being inputted right here. So if you take a look right here, and I'm just casting this as an attribute. So I just put this at sign right there, and they're going to be cast to the primitives themselves. So what this is doing right now is taking this primitive number. So each primitive has its own number and it's unique, and we can use this in our advantage. And using the random function, taking this primitive number as an attribute, we can create a unique value for each of these primitives that just gets assigned randomly, you know. And if you, for example, come here and sort them by the selection number, so you're gonna see the highest value by chance is the primitive number 5, 4, 3, and so on. So this is great. And next step, we could say, for example, all right, we have this, and I wanted to, for example, if, let's make an if function, if statement, variant, open close parenthesis, open close this curly brackets, just so we keep it organized for ourselves. And I'm gonna come inside here, the if, and I'm gonna say, okay, if this cell, all right, if this selection is smaller or equal, okay, to 0.1. Let's for now just hard code this, and then we can just make a parameter to control this afterwards. And if this value is smaller than 0.1, so this means that we are selecting 10% of our primitives, okay? And I'm just gonna create a group for that, and the syntax for this is quite simple. So you just go add, type group, and underscore, and I'm gonna say selected group selected. Okay, this is the name of our group, and I'm just gonna say this is equal to 1.0. All right. And I'm just going to go back here. Before the add sign, I'm just going to type F. So you're casting, you're saying this is, excuse me, a float attribute, all right? So it doesn't give you any warnings or anything like that. I'm just going to hit enter, or just click out. And you're going to see that it changes right here what's happening, okay? So you created a group, all right? You see there. And if you go through the values, you're going to see that roughly 10% of these primitives are being selected. Okay, so there you have it. Because by chance, these are the primitives that got assigned a value of between 0 and 0.1. Okay, and next on, we could, for example, come here. So since we hard coded this right here, this value, we could say, all right, give us a slider to control this, so we can control this from outside the code. I'm just gonna type ch as in channel, open and close brackets, parenthesis or better, and I'm gonna type the name of the parameter that we want to create, right? So I'm just gonna call this trash. Oops, I forgot a H there. Threshold. All right, just gonna click outside, and there is this little button right here that will create sliders that it encounters inside the code. So when you click that, you're gonna see right at the bat this gets created. So for now, the group, since this is 0, nothing is being selected and being assigned to this group. So I'm just gonna type here, for example, 0.2. And you're gonna see if I middle click here in the primitive wrangle, you will see there is a primitive group there called selected, and it has 205 elements assigned to it, and this is roughly to 20% of the incoming primitives, because you can see there are 1024 primitives coming inside. So, and I'm just gonna, I don't know, just type it right, 0.5, so this is 5% is being assigned to the group of the selected, okay, which is great. And let's just keep seeing what we could do with this data that we created. So first of all, since we were just debugging and using the geometry spreadsheet to take a look what we were creating, I would recommend, if you're not going to use this or you don't need it anymore, you could just cast them to floats, so they won't be attributes anymore. Alright, so you could just delete the @ sign right there and delete this @ sign, so everything that's here, it's going to disappear except for the group, because the group will always be shown here. Alright, so it's still working. And we could, for example, jump now inside the our for each right here and tell, for example, for this poly extrude right here that we created before to run over only the selected group. Okay, so this is going to happen right off the bat. All right, and we could, for example, right now just copy and paste this extrude. Okay, and make it run on the on the elements that don't belong to any group. So we could then merge these two together. Excuse me. And if we output it, actually we should get just the same value as we had before. Okay, but now with the advantage that we can say, we can come here and say, okay, these extrusions of the selected ones, we would like to make them times 1.5 for example, to make them always higher, and here as well. So let's see how it looks like, and you can see right off the bat this gets extruded in a different manner, and our primitive wrangle right here can still play a part on this. So we can say, all right, instead of 5%, give us 30% of the elements. All right, and if we wanted to give us some more control over this, we can even come right here. Since this is a function and it can take another argument, we can just come here and say would like to make the seed of this random function to be the primitive numbers plus some sort of controller for us. So I'm just gonna go type in ch and create a parameter for us. So just a slider, let's just call this random seed. Okay, I'm just gonna click on this button right here, so this gets created right here, and if we change this value, these numbers get recalculated, and we've got ourselves this little extra layer of control right there. So this is great. Another technique that I would like to show you. Alright, so this is just a random thing that we're doing right now, okay? But what about how could we select these elements based on their sizes, okay? So for example, right now we have these big chunks also being selected randomly, since this is just by chance, okay? But what if we don't want that? What if we only want, for example, the tiny little ones to be selected? And this could also render some interesting effects. So let's just leave it to the side right here for now, okay? And let's think about this for a second. We have the incoming primitives here, okay? And we could use this Measure SOP. Okay, this is going to measure the area of every primitive. So you can see by default it gets created this parameter, which is the value. For example, if you would add each and every side together, which could be also used in this case, but just for the sake of it, I'm gonna go with area. It gives us I don't know, I just think it's better. I prefer this. And for example, we could now append a delete SOP, okay? And there is the possibility of coming in right here and deleting by expression, alright? And for example, if I come here and filter expression 1, that's not what we want, we can just type at area. Since this is an attribute, we can reference it here. Since this is a filter, it's an expression, so we can type area, and I'm just gonna type smaller, alright, then smaller or equal than 0.0 I don't know, let's just see one, how it looks. You can see right at the bat some of these values get deleted, some of these primitives, and I don't know if this is a good value or not, so let's just search for a value that we think it's good. And similar to the previous technique that I showed you guys, this could we could like maybe copy and paste this right here, and delete the non-selected, right? So there you have all the elements, the smallest elements of our selection, which is great. And we can do just like we did before. I'm just gonna do this one from scratch again, so it doesn't get a bit confusing. I'm going to append a SOP. I like to work with on the left side with our selection, sort of, and at the right side the rest. So I'm just gonna append this right there, and I won't do this in much detail like it did before. So this has all been covered. I'm just gonna try and do this a little bit faster this time. So if you put an extrusion, I'm just gonna copy the expression that we used before. Just gonna paste it right here. All right, and I'm gonna click Alt E to check what is being done. For now, I'm gonna leave it right there like this. So there is just one thing that's extrude either doesn't exist, or better, it's being referenced to this one, and this has nothing to do with this one. Okay, so whenever you create new loops and you're using referencing to these types of these nodes, you better always check. So I'm just gonna call this size either. Okay, I shouldn't have put the display flag on, so I'm just gonna go back here, and since this is the size selection mode that we are creating right here, so just gives us a heads up what is happening. I'm gonna make us some room right here, and if I copy and paste this to the side, the size either I can push to this side right here and connect this other delete node right there, and I'm gonna click Alt E here. I'm not going into much detail of how you can control or how can you change these values, because the principles that I showed you before are more than enough for you to create your own controllers right here and assigning them separately. So just go ahead and do that if you would like to. And I'm just going to merge these two together. All right. And so there you have another way of sorting these primitives. And if you compare these two, you're gonna see there is a huge difference in the results. Okay, since this is also selecting some of the biggest primitives right there, and if it's not what we want, you could go with this alternative with the Measure SOP, which selects only the smallest ones. So this could also be done via a primitive wrangle. Of course, everything can be done through this, but I think this was maybe enough Vex for today. If you guys are feeling a little bit on the challenge and you'd like to tackle this on the primitives wrangles, feel free to do that. It's a great exercise. I've been doing this quite a lot lately, always trying to build my own stuff with primitive wrangles, trying to use more and more Vex into my workflows, because it's such a great and powerful tool that in the long run it's definitely gonna pay off. So I think this wraps up this second part and how we're going to select this type of stuff, and how we can generate different outcomes to our little k-dimensional tree. This space partitioning algorithm that we created here using very simple techniques so far, and I hope next I could show you some overview on how to set up a very simple scene, and even take this to the render level. I think this would also be interesting to show you guys how I have been rendering my stuff with Mantra inside Houdini, since this is also a very powerful tool. And I hope you guys enjoyed this and could have learned a little bit from it. Okay, so take care, guys. See you next time. Thank you so much.